All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So we're going to say, let's find our centroid of our object shown. So we have just a random shape in here. Where is its centroid? The x and y coordinates for this. So the first thing we need to do is come in and say, if we're trying to use our table, and I've broken this up and gotten the table in here for the shapes I'm going to break it into. But we should be really saying, how do I break this up into easy to work with shapes? Things that have our centroid table probably in the back of our book, that we can find this online as well. But how do we work with that? So I'd say, well, I have a rectangle here that's 6 inches wide, 4 inches tall. Let's come in and call that shape number 1. So this right here is shape 1. I also have a semicircle up at the top with a radius of 1.5 inches. Let's call that shape 2. So up at the top, this is shape 2. And we're just going to number off our shapes just to make it easy to follow our work. And that leaves us with just a triangle down at the bottom right that I will call shape 3. 2 for the semicircle, 3 for our triangle. 3 shapes, which means I can break it into 3 pieces. Come and work with that. If we're doing this, I would encourage you, make a table out for this. For my students, I tell them if they don't make a table, I'm going to mark them down because it really is building towards if you were doing this in a job, you tackle in Excel. Excel sets up great to have things in a table. Also, though, it makes it really easy to follow your work or to change anything. It's easier than having a giant equation written out, even though functionally it's going to end up doing the same thing. But so if we're making a table with this, I'm going to come in and say the first thing I need is, I know I need a handful of rows for this. My first row, I need a row for every shape. So I broke it into 3 shapes. So I need shape 1, shape 2, shape 3, and at the very bottom, we need a summation row. This is our shape number. Shape number 1, 2, 3, and our summation row. Our next column, if we think through our centroid formulas, our centroid formula was, in general, our x bar is equal to the sum of our x distance to the center of an individual piece. I'm going to use x tilde for that, times the area, divided by our total area. Centroid is x tilde a divided by the total area. So I need columns for each one of those things. And we could also do that for y bar. Y bar is the sum of our y tilde a divided by our total area. So a couple columns for us to come in and make. I need areas for both of these, so let's make an area column. Area. And that would be in, our units here are in inches, so our area should be in square inches. That'll be our next column in there. From there, I need an x tilde and a y tilde column. Let's just put those in. X tilde. That should be in inches. And I need y tilde. Just one column for every variable we're setting up. Y tilde also should be in inches. And then the last 2 things I need, I multiply x tilde in my area and y tilde in the area. Let's just put in a column for those. So I'd have an x tilde a in inches cubed. And our very last one in here, I would need a y tilde a, also in inches cubed. Inches cubed. Trying to write that small so it stays below my table in there. So we're just going to fill in this table as we go through this. So the first thing, what's our area of our rectangle? Well, I'm going to put in my basic numbers in here as I fill this in, just to show my work. My base of this is 6, my height's 4, my area then is 6 times 4, 24. For a semicircle, we know the area of a circle is pi r squared. So our half circle should be pi r squared over 2. If we forget that, there is in our centroid tables, pretty much all of them have an area column in here. So pi r squared over 2, we're given that. So this would be pi times my radius we were told was 1.5. 1.5 squared over 2. Or this is 3.53 square inches. And then finally, our triangle we know is 1/2 base times height. So we can come in and fill that one in. 1/2 Our base of that triangle is 3. And the height is 4. 1/2 3 times 4 is going to get us 6. In my formulas, I have a sum of my area. So let's sum this up. If I add this up, 24 plus 3.53 plus 6 gets me 33.53 square inches. And that's one of our columns. From here, we're going to come in and start trying to find our x tilde distances. So we want to pick one common point where we're going to measure every single one of these values from. Just choose the y-axis for that. So I'm going to say, what's my distance, for example, from the y-axis to the centroid of each individual piece? This will be a y tilde or an x tilde for shape 1. I'm going to need to do that for shape 2. So I come from the x-axis out in the x direction until we get a third of the way into our triangle. That would be my x tilde for shape 2. And I do that exact same thing going to my semicircle. So what's my distance here? Still measuring from that same common starting point, my y-axis. This would be x tilde. This one would actually be 2. This one down here should have been 3 because it measures to shape 3. So we'll change that. X tilde 2, x tilde 3. 3 x tilde distances, though. I need to find every single one of them to really set this up. So for shape 1, we're going to come in and say, well, measuring from the y-axis, my rectangle sits right there on that y-axis. In my centroid formulas, we're told if I measure from the edge, my x bar, that value here to the centroid of the rectangle, is just half the base. So I can directly apply that formula. I'm starting at the edge. To get to the middle is just half the base. We're 6/2. Or this is 3. For my second shape, if we look at our formulas, the y centroid, which would be an x distance into that, is just in the dead center. So I need to get from the y-axis to the middle of that rectangle, which if I'm doing that, I could really write this as, well, to get to the far right edge, I'm going to come in 6 inches. 6. And then that gets me from here to the right edge. I'll only subtract out the radius to get into the middle of it. So 6 minus the radius, or 6 minus 1.5. This is 4.5. And then finally, for the triangle, I need to get, we know our centroid of a triangle measures from the 90-degree angle in a triangle 1/3 of the way into it, which is what we're seeing in here. From our 90-degree corner, we'll mark it in here even, from the 90-degree corner to the centroid is our x bar in the x direction, base over 3. So our x tilde here, and our composite would be from y until we get 1/3 of the way into that triangle. So I can't directly just say it's base divided by 3. I need to first get to where that centroid formula applies. From the y-axis to the 90-degree corner is 6 inches in. So 6, that gets me to right here. And then I go an additional 1/3 of the way in. So 6 plus the base over 3. 6 plus 3/3. Would get me 7. So that'll be my next value in here. I never have a sum of my x tilde, so let's not worry about summing this column up. It wouldn't hurt if we did find it. It's just not a necessary thing to solve our problem. That same idea would be true for our y tilde. We don't need to sum it up either. So we'll just cross it off. That finishes our x tilde. Let's come in and get y tilde distances. So we're going to change this, and just like we measured from the x or from the y-axis in an x distance to get x tilde, we can measure up in the y direction to get y tilde values out for everything. So I'd have a y tilde for shape 1. Y tilde for shape 1. Measuring from the x-axis to the centroid of shape 1. Same thing for shape 2. What's my y tilde value here? Y tilde for shape 2 would measure from the x-axis all the way up to the centroid of shape 2. And then finally, for our third shape, we again have a y tilde. This would be y tilde for shape 3. From the x-axis to the centroid of shape 3. So we just need to find all 3 of those distances and do a little bit of algebra. But so my y tilde for shape 1, well, my centroid formula says it's in the very middle. If we measure from the bottom up, just half the height, our x-axis is at the bottom of that rectangle. So we can just go halfway up into it. Our centroid formula applies directly from the x-axis on this. So height divided by 2, 4 halves, or we're at 2. For shape 2, we have a messier centroid formula. We're told that from the flat side of a semicircle up into it, the centroid should be, that's that y bar, we should be 4r over 3 pi. Also, this one wasn't given in here because it's just the very center of it. There isn't a formula. We're measuring from the middle of it, and we don't go anywhere. But we need to go do 4r over 3 pi here. But again, before I can apply that, I need to say, what's my distance from x up to the flat side of the semicircle? And that would be my 4-inch distance. So 4, once I get there, I can then apply 4r over 3 pi. What's that extra distance from the flat side to the centroid? So 4 plus 4 times 1.5, I'm just going to write it as 4r over 3 pi. 4 plus 4r over 3 pi, where we know our radius is 1.5, was given to us. This is going to get us to 4.64 inches. And then finally, I need to do that for shape 3. For shape 3, I can say, well, my centroid formula measures from the flat side of the triangle, from the 90-degree corner, up 1/3 of the way into it. Y bar is h over 3. So really, I just need to come in and say, well, that measures exactly where we start out this triangle at. We're starting at the bottom here. We're at that 90-degree corner for the x-axis. So I just go up 1/3 of 4. 4/3. Where this is 1.33. Which really, for this problem, I would say is the bulk of our work, getting these x tilde, y tilde values set up in here. My next two columns are just algebra in here. What's my x tilde times the area? And we just go straight down that. 24 times 3 is 72. For the next one, 3.53 times 4.5 will get us 15.9. 6 times 7 is 42. And if we look in here, I do have in my equations, a sum of my x tilde a. So let's add this all up. I get 129.9. And we'll repeat that for our y tilde a. Y tilde 2 times 24 is 48. 4.64 times 3.53 for shape 2 is going to get me 16.4. 6 times 1.33 is going to get me 8. And adding that column up, because I have a sum of my y tilde a, I'm going to get that my total y tilde a is 72.4 inches cubed. Which really gets me everything I need to apply my centroid formulas. My last little piece in here, I can just say, well, my x bar should be the sum of my x tilde a, which if we set up our table, this is really easy to grab then. 129.9 divided by my total area, 33.53. Or that x bar is going to get us to 3.88 inches. 3.88 inches. And my y bar, I know is the sum of my y tilde a divided by my total area. Y tilde a added up to get us 72.4. And my total area is still 33.53. Or my y bar is going to get us to 2.16 inches. 2.16 inches. Which should be our second answer. For our tilde distances, I should have one number for every single shape I broke it into. For x bar and y bar, I'm going to get one answer for the entire thing. Also, some people would write this as x bar 1, x bar 2, x bar 3. It's the same thing. It's just how do we learn that? It's a little bit different. I use a tilde just to make it extra different from the x bars. It helps people understand what's going on. But if your professor uses an x bar 1, x bar 2, it's really the same thing as my tilde distances. But if we came in here, we could label that. I had a centroid of every individual piece. I have one centroid, though, for the entire object. Should be, I have an x-coordinate and a y-coordinate. 3.88 in, if this entire thing is 6, we'd be about here. And 2.16, a little bit past halfway in, maybe about right here. That would get me my centroid. Would be right at that point, the blue dot we just put in. 2.16 up in the y direction from the x-axis, and 3.88 in the X direction, measuring from the y-axis in there. But hopefully this is a useful video for us. If it was, hit those like and subscribe buttons. Stick around. Let's watch some more videos. Let's get you an A with JJ.